Oh! 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 Ow! Hi, welcome to canispaterchristmas. This video is going to be a slight departure from my normal RGB pixel videos in that I am going to show you how I'm using RGB pixel strip to light my stairwell. Now, to drive the pixels, I'm going to be using a NodeMCU module, and this will be used to set the color of the lights based on the temperature and light level outside. There's no timers involved. So if it's during the day and a large thunderstorm comes over, or we happen to find ourselves in the path of totality during a solar eclipse, or maybe a large alien spacecraft comes and parks itself over our house blocking out the sun, the stairway will be lit. So what started all this? Well, I had purchased some Lutron light switches and put them in various places throughout the house and controlled them with HomeKit on my phone. But HomeKit really isn't a home automation system. I recently discovered a home automation platform called Home Assistant. Now, Home Assistant is open source. It's written in Python 3. It's distributed as a Docker image, and it is under active development. So there's a lot of people making changes to it every day to improve it. Now, if that last sentence sounded like a foreign language to you, don't worry about it. You don't need to know all that. However, if all that wasn't neat enough, it also runs on a Raspberry Pi. Now, if you know Python and you'd like to help, there is a GitHub repo that has the actual code, but as a user of the system, you don't need to know Python or Docker. Another cool thing about Home Assistant is that it runs as a self-contained application. You just make changes to configuration files, text files, and then Home Assistant reads those in and makes decisions based on that. Now, you will want to keep a backup of those and back them up pretty frequently because they are your configuration. You will spend a lot of time working on the configuration, making tweaks here and there to get it set up just the way you want it. It's kind of like working on a display. It's never really done. Nothing I'm about to show you is my original idea, except for putting all the components together to accomplish what I wanted to do. So what did I want to do? I wanted to put some LEDs on my stairwell and have them come on at night for pathway lighting. If we want to use the stairs and it's dark, I wanted them to be lit well enough to where we could actually use the stairs, but not so bright that it would be a distraction. I also wanted them to give an indication of outdoor temperature in case we were headed outside and we could be prepared. If it's between 70 and 80 degrees Fahrenheit, it's just right, so the lights will have a green tint to them. And if it's hotter than that, it'll be a red tint. If it's cooler than that, it'll have a blue tint. Now, I can change this in the future, like, for example, if it's below freezing, I could have some sort of pattern, but that's a future enhancement. I'm going with this for now. Now, I know at least one of you is thinking, well, why can't you just turn a light on? That's not the point. We're going a little old school here, but let me draw you a diagram. So this is Home Assistant, okay, and this is running on the Raspberry Pi. So we're going to have a little node module here, and that's going to be the sensor, okay, and that's going to be temperature and light level, okay. Then we're going to have another module here that is the pixel controller, not personal computer, but pixel controller, and this will have the actual lights to it. I've got my little lights on there. Okay, can you see? Now the problem is, how do we get Home Assistant to take data, or get the sensor to talk to Home Assistant and then Home Assistant to talk to the pixel controller? We have something called MQTT. And it is just an app that does a store and forward. So you're basically sending JSON between all these things. So the sensor will send a packet to MQTT. Home Assistant will read that, process the data, and then if it needs to do something, it will send something back to MQTT, and this guy will read it and set the lights to that. So you need Home Assistant and MQTT running. Now MQTT can run on the same Pi as Home Assistant, or you can run it, there's a cloud service I believe, and you can also run this on a different machine. It always has to be running though, so for example I have a Linux box that's always running, so I'm running MQTT on that box. Home Assistant is the only thing running on the Raspberry Pi. So you can set this up however you want to, but you will need to go through MQTT. Alright, the first part is actually installing Home Assistant on a Raspberry Pi. So go to the Home Assistant homepage and click on Getting Started. Now read through that page if you haven't already, and when you get down to the Software Requirements section, click on Download HOS.io image for Raspberry Pi 3. You might also want to download Etcher, which is a program to write the image to the SD card. It's available for Mac, Windows, and Linux, and may be useful for writing other images to SD cards that you may be using. You can follow the instructions on the page for going through the installation, or just follow along with this video. I'll take it step by step. Insert the SD card into your SD card reader and writer. I'm going to format it, use SD card formatter, and just do a quick format. Formatting will erase everything on the card. Yeah, that's fine. This should go pretty quickly. And we are done. Now we go to Etcher. We're going to select image. I have it on the desktop. It is this Resinos HOS.io 1.3 Raspberry Pi image. I will open, and it's chosen our SD card, and so we hit flash. And we are flashing. Insert the card into the Raspberry Pi. Connect up a network cable. Connect up the power cable. And plug it in. And we wait about 20 minutes. Don't worry about hooking up an HDMI cable to the Pi, because all you will see is the Home Assistant logo. It doesn't actually give you any kind of progress indication. You can go to a browser to hosio.local port 8123. It will continually refresh until the thing is finished loading and Home Assistant is running. Okay, we can see that we have our welcome page here. The Sun and YR symbol is automatically loaded. We have some getting started help here, and it looks like it detected my Apple TV player. Now if you go to this menu over here, there are a couple of things that you may be interested in. Go to the HOS.io section and click on the add-on store. You can load this mosquito broker. Configuration, you will be in here quite a bit. You will do a check config quite often. Anytime you make changes to the config pages, do a check config before you restart anything. This is the Amiga NodeMCU module. This is my new favorite board for all this stuff, really. It has the ESP module built into it. It's also got a serial connection, serial driver, so you just have to connect a micro USB cable up to it to program it and to read the serial, or read the data back from the serial port. Very cool little board. To get the code for the NodeMCU module, you can go to GitHub. I'll include the link in the description. The project is ESP MQTT JSON multi-sensor from Brew Automation, or Bruh Automation. Go down and click on clone and copy, and then I go to the command line and just do a git clone and paste that in. It will download that, and then we can open that in the Arduino IDE. read through here. If it doesn't compile for you, then you may be missing some libraries, and you can check the compile just by hitting this check mark here and see if the sketch compiles. If it doesn't, you're probably missing a library. So here is the URL that you will need to get the ESP modules added to your IDE. You just go to Preferences and paste that in here. And then you will also need these libraries. So if you don't have those, you will need to get them. And it looks like we compiled okay. So I have everything that we need. Now, at the top of this, you will need to add in your Wi-Fi SSID and password, your MQTT server IP address, the user, and the password for your MQTT, or that user and password for MQTT. This is the MQTT topic that will be sent by the sensor module, and this is the one if you want to set the light. If you want to be able to update the code once you put this on your network, you need to enter this password or just type in new password. Now, one problem that I had was this MQTT max packet size. This is actually part of the PubSub client library. You're supposed to be able to just set the define in this code, but I actually had to go in and modify the header file to get it to work. The max packet size is, I believe, 128. By default, or that's how it's defined in the library, and you will actually exceed that with this project. So it does need to be, I don't know, it's over 300 or something, but go ahead and set it to 512. Go ahead and make that change in the header file of the library. Wherever the Arduino libraries are on your system, just go into libraries, the PubSub client source, and this header file, and change that to 512. I'm guessing the libraries load prior to this being set because it never did work for me. So once you connect the NodeMCU module to your computer, you may have to restart the Arduino IDE to get it to recognize that you're plugged in on the serial port. And then all you got to do is hit upload, and it'll compile and just send it to the module. Now, once you get all this programmed in, you can go to this example Home Assistant configuration file and pretty much just copy all that in. I think it depends on your MQTT setup, but this is the actual LED light if you use that. Other than that, you just need the sensor stuff. So this is the humidity sensor, this is the light sensor, and it says it's lux, but it's just a voltage range between 0 and 1024. The PIR sensor detecting motion and temperature, and then there's a calculation in there to give you the real feel or heat index, and then add this group to create a little card for all those things. Once you add this data to your configuration and restart, you should be getting the data into Home Assistant. And if you scroll down the page, there is a wiring diagram how to hook all these devices up to the NodeMCU, so check that out. The light sensor comes with this little 3-pin header. It's the only piece of this that actually needs solder. A little bit of solder on there and it'll fix it right up. This little PIR sensor is very sensitive, not marked real well, and doesn't have any adjustments for sensitivity or delay. This is the light sensor. Now this one I think probably has some sort of issue, because if I turn this light off, it is just freaking out. It is just updating left and right, and my other one doesn't have that. So I think there's a problem with this light sensor, so I'm gonna just turn that off right now. So this is the NodeMCU module. This is my motion detector, and you can see that it is detecting motion now. Let it quiet down, okay. But it's pretty good at detecting motion. Okay. And then now the temperature and humidity sensor. So we're getting some changes on that. I packaged all of that in a very attractive, readily available container and hung it outside my front door. And so this one is to drive some LEDs. And so he actually has several videos about how he did this. On the wiring diagram on the page, he needed to use a bidirectional level shifter. I was able to not have to use that because the distance between the NodeMCU and the first pixel was very short, or is going to be very short, so I was able to drive the pixels without it. If you have a longer distance between the first pixel and where you have this NodeMCU, then you may need this. I am using a buck converter to convert 12 volts down to 5 volts, and then I have this little 12 volt power supply here. He power injected, I think he had probably 10 meters of pixels. I've only got less than 5, so I didn't do any power injection on this. And here is the example configuration changes. I think this MQTT stuff is the same. This is to control the light. This has all the different effects that he has programmed in there. There is a slider to adjust the animation speed. The connections for this thing is I have a standard cell phone charger that is powering this module. This ground wire goes over to a 12 volt power supply I have over there. The 12 volt power supply is for these lights. Eventually I'll just come into this module here and then there won't be a need for any power over here. Coming out digital pin 5, and that is connected, you can't see that. That's connected to the data wire, the center wire on the pixels. So this red wire is plus, this blue wire is minus, this green wire is data, and so this D5 is feeding the data line on the other end of this string. So what we can do with Home Assistant is actually control these lights. So this includes several patterns that are written in the software. I got some of these little aluminum channels. They come with a diffuser, and it's just a little aluminum channel. You can put the strip right down in there, and then you can just push it on there like that. So there's the end of it. These are each 1 meter in length, and they come 5 to a package. And it comes with this mounting hardware. This is to put on the end if you want to run wires through it. This is if you want to put on the end and don't want to run wires through it. These are little holders for the rails themselves, and then the screws to mount the rails. So here's the rail. I'm going to mount it to this piece of wood because it goes all the way down the steps, and I'll probably leave just a little bit of space here to keep it from snagging, and I'm also going to put one of these right on the edge so that it'll also keep from snagging, and then I'll put one of those caps on the end here. So let's get started. The Home Assistant configuration was the tricky part, and I say tricky only because I was just getting started with the platform. First, I created a binary sensor called isDark. Now, the light sensor ranges from 0 to 1024, so I just picked 100 as the trigger point. If it's below 100, isDark is on, and 100 or above, isDark is off. I may adjust that if needed, but that's what I have for now. Then I created an RGB temp sensor to set up the ranges that I wanted. Using a value template, I set the value to hot, cold, or just right. So 80 or above, it's hot, 70 and below, it's cold, in between, it's just right. Now for the automation, if isDark changes to on or the RGB temp changes and isDark is on, I send out an MQTT payload to change the strip to the proper color. So if RGB temp is hot, I send out 255, 100, 100. So the light has a red tint to it. It's still mostly white, but it does have a red tint. I'm also setting the brightness level to 6 with 255 being the max. I don't need a lot of light, just a little. This also reduces the power consumption quite a bit.
So I was going to use this little bud box to mount the electronics in, but as you can see, it's just a little, the box is a little too small for the electronics. So I have another one on order, but I think it's on a ship from China or something. So this is my current box that I'm using. Kathy's really happy about this one. And then I'll put it in the box as soon as that one arrives.
I have been using these for about a week now, and it seems to be doing what I want. Although I may have to add some more lights to complete the pathway to the kitchen. As for the lifetime of the strips, I really don't know. They will be running quite a bit, but they're also running very dim, so I'm hoping that extends the lifetime a little bit. Check back in a year. So did I go through all this trouble just to put some lights on my stairwell? Well, yes and no. So I had to go through all this stuff to set that up, but now that it's set up, I can do other things. What those are at the moment escape me, but I'm sure I'll think of something. So this is just a little practical project that I worked on. I thought some of you might be interested in, so that's why I made the video. If you have any questions, leave them below. Other than that, thanks for watching, and I'll see you again soon. And all the dogs run.
And we have a jet flying over. There's so many cars going by.